Hello, I am John Forman. I'm a Senior Technical Architect Manager and the North American Kubernetes Practice Lead at Accenture. In addition to my role at Accenture, I had the pleasure recently working with the Linux Foundation and the CNCF to spearhead the creation of the new certified Kubernetes security exam. Look for it coming to you in November. The agenda for this presentation is as follows. First, we will discuss security challenges, then the container security approach, followed by evolutions of DevSecOps, and lastly, real war stories from the boardroom. Security challenges. It's no secret that containers are taking over the world. During the last year and a half, I have seen containers move from the client basement to the client boardroom. However, while they were going full steam ahead with containers, security was a second thought. No one understood containers enough to deploy with best practices, let alone how to secure them. So, not surprised that container security is the number one challenge today to overcome when deploying containers. Now is the time to shift left to defense in depth, to security in depth. For years, defense in depth was the answer to questions for business leadership. But in today's Kubernetes threat landscape, where many cyber criminals are sophisticated enough to circumvent layered safeguards, the old defense in depth philosophy no longer applies. Defense in depth is a military strategy designed to create layers between an attacker and the primary goal, which, in the context of enterprise cybersecurity, this is usually the company's most valuable assets. If one layer is broken, the next layer will take over. Whereas the security in-depth approach, security risks are identified and mitigated by integrating security tools at each layer of the container architecture levels. How security breaches affect the organization. In 2019, $1.41 million was the average cost to an enterprise organization for a single security breach. The top three expenses to an organization following a breach are increased insurance costs, cost of bringing in consulting firms, and third, loss of business. Approximately 32% of the total cost of a single security breach is dedicated to improving software training and adding new staff. Security vulnerabilities affect everyone. There is a variety of factors contributing to the increasing levels of application level security vulnerabilities. Developers of these applications may not have the expertise or resources needed to prioritize application security and frequent ongoing maintenance. In addition, operating systems age and near the end of official support. Organizations continue to utilize systems that do not have new security flaws being remedied regularly. This, in return, is what causes the high number of vulnerabilities. Let's not forget that part of good security hygiene is to keep your operating systems updated. With the innovation of Kubernetes, there comes new security challenges. And the security tools of the past, rack and stack deployments, no longer apply. New vulnerabilities such as kernel exploits, vulnerable library exploits, cross-host container attacks, compromised secrets, and vulnerable application exploits is a new attack landscape. There continues to be growing demand for application security. Clients need real-world solutions that can integrate with these application lifecycle. In addition, artificial intelligence and machine learning is quickly maturing to enhance these security tools. And this is creating a high demand for new skills across IT and InfoSec. Culture matters. And governance cannot be an afterthought as this evolves further. So, what are the high demand skills? In 2020, from my perspective, Kubernetes, DevSecOps, the emergence of a true multi-cloud hybrid control plane, and service mesh are the highest in demand. And I see Jenkins, expert multi-cloud knowledge, Terraform Ansible, Docker, and containers and service platforms as a skill that is in demand. As Kubernetes further matures, so will these skills. It is important that we enable our IT staff with these critical skills. If you are asking yourself, what skills or certifications do I need to become an expert in? The hot skills listed on this page should be in your toolbox in 2020 and beyond. Not only do you need to know how to implement them, you will also need to know how to secure them. Container security approach. The approach for container security is different than the security model used for the typical monolith architecture applications because they provide a unique set of security-related advantages. Although challenges with security patching and security updates is common practice, however, with the scaling of containers, this could become a significant challenge. And keeping containers immutable and in isolation is a new security paradigm for us where we need to rethink container security. What are the security levels recommended for a good overall Kubernetes security posture? When I discuss Kubernetes security maturity levels with clients, I start from the cluster setup up to prevention. The far left is the most basic of Kubernetes security. General guidelines at this level include things such as never run Docker on an unsecured, unhardened host. Remember, Docker is only as secure as the underlying host. Verify that all security settings properly enforce the policy. Use the latest stable Kubernetes version possible to gain the latest security capabilities and fixes. Audit the operating system, container runtime, and Kubernetes configuration using CIS benchmarking and other tools like Kube Order Analyzer and Kubebench. Log everything to a location outside the cluster. Disable the insecure port, even on your local host. And disable anonymous authentication. As you further mature in the Kubernetes security journey, you start using things like minimum images. You disable unneeded GUI dashboards. And you start scanning your containers for vulnerabilities using best-in-class tools like Snyk. Then up to prevention, where you use policy as code and service mesh for true pod-to-pod encryption. This journey from left to right is not overnight. There's layers of complexity that you must manage, including governance policies and procedures, which need to become a critical part of the journey. When I work with clients, I'm getting them proficient and able to scale with Kubernetes. In addition to the previous slide, I also start with a 5-point scale. In addition, there should be no surprise that most clients are at level 2 today. At level 2, they have a standardized set of tools for certain functions and started scanning the containers at build time and rest. My goal is to get them at a level of 4, where they have a mature capability in place to support DevOps or becoming subject matter skilled experts and have runtime scanning enabled. And ultimately, they can scale to level 5, where they can do really cool things, like data ops and blueprint deployments. So, how do we secure Kubernetes? We start by identifying the security threats in the Kubernetes architecture and the potential threats associated with it. We start with the cluster, where we have a collection of nodes. The nodes can be exposed if an attacker can get control of the container. If the attacker controls the nodes, they can also control the pods that runs on them. From there, they can go play in the masters and workers. From the master, the attacker can control the cluster. And if this happens, they can attack SED. And then it's game over, because they can destroy the entire cluster. Let's deep a little deeper into the attack surface. There are attack vectors to address, from the container down to the network. You need to think about, how can I reduce the attack surface? Kubernetes, again, is a very complex system. In order to mitigate the blast radius and reduce the attack vector, we want to do things like using a minimum image. We only want to build all images with libraries and drivers that we need to run the specific transaction. We don't want bloated images. Trust me, no one cares about the HP4 LaserJet driver. We just don't need it. Trust me. Containers provide security through isolation from the host operating system. However, containers in production environments are still exposed to known security threats and risks that must be eliminated or mitigated. In this diagram, we use the most common container security risks to help facilitate the identification of the right set of security tools and platform technologies to protect the containers. The security areas in the right column provide the high-level characterization of the security features required in container security tools. The security areas that have identified are secrets management and data encryption, runtime scanning, registry, incident response and forensics, image signing and image verification, and lastly, artificial intelligence and machine learning. Evolution of DevSecOps. Today, DevOps has evolved to DevSecOps, where security is a first-class citizen in the development lifecycle. With DevSecOps, security is shifted left into every step of the product development lifecycle. Not only do we scan the source code for vulnerabilities, we also sort our container images to allow the ability to know when we are compromised instantly, and continue to monitor in runtime after it leaves the DevSecOps pipeline. It still amazes me that many clients still do not monitor the Kubernetes clusters in runtime. Sure, in best practice, our containers should always be immutable. But are they? Shifting security to the left will further help you develop and release your applications at scale. Key features include automation of security, agility, continuous development, integrated quality, automated testing, speed, adaptability code base, and a single pane of glass for monitoring. Many times I get calls from clients after the security incident occurs. This practice cannot continue. And I continue to stress, security must shift left and become a first-class citizen. Now remember, we can never guarantee zero risk. even after our clients invest in the latest, greatest tools and technologies for security. There's always the human element, as social engineering is always prevalent from both insiders and cybercriminals. We can all remember Kevin Mitnick, who back in the 90s successfully hacked and became one of FBI's most wanted, with his key skill being social engineering. In 2020, we are looking at more and more ways to integrate artificial intelligence and machine learning into our applications use cases. At the same time, attackers are looking for ways to integrate artificial intelligence and machine learning tools within their attack tools. We need to be aware of this growing global effort by cybercriminals to attack using robust AI-driven security strategies. And we need to use best-in-class tools within the Kubernetes ecosystem to combat the bad actors. We need to be running artificial intelligence and machine learning capable monitoring tools. To future-proof your Kubernetes deployments, you need to provide user behavioral analytics and provide deeper analytics threat feeds for forensic analytics. By using vendor solutions that has artificial intelligence and machine learning tools built into their architecture to perform analytics on your centralized logs data is your best line of defense. Real war stories from the boardroom. Let's discuss some of my war stories from my point of view and past experiences with working with our clients. One client I would like to talk about was experiencing significant issues with monitoring the PKI certifications. It was the Wild Wild West. There were developers on the separate teams doing their own DevOps pipelines with the lack of any type of governance. And the client was unaware with what certifications were expiring when. They literally had thousands of sites with no idea on what was expiring when. This was very complex as it was multi-cloud. They were using Amazon, Azure, and GCP. Our solution was to develop a fully automated DevSecOps pipeline in a multi-cloud environment that streamlined the PKI certifications process that spanned all the clouds with a one single DevSecOps pipeline. We worked directly with HashiCorp to help engineer the first multi-cloud PKI solution in the industry that truly can scale. In addition, we developed a Kubernetes platform maturity path model to further assist them on the journey. And lastly, we helped with building an onshore, nearshore container factory to help scale the application modernization journey. This was a true case of where it is critical to have governance and processes around Kubernetes journey at the beginning. Next client I wanted to discuss deployed 51 containers in production, and after doing a scan, they had over 64,000 vulnerabilities discovered. The client was in a panic. These containers have been running in production for several months. And because they had no real Kubernetes security hygiene, they were running at a high exposed risk. After digging into the vulnerability report, we had discovered three main causes of these vulnerabilities. The first one, insecure libraries versions within images affecting libraries due to outdated base images. Number two, outdated clusters by several months that have not been updated to the newest versions. And third, outdated images more than 3 months old, and one of the images used for testing was 4 years old. It was observed that around 90% vulnerabilities may be removed by simply upgrading the images to the latest version. After we did our complete analysis, the tasks included in the plan to resolve were, number one, use Snyk not only to integrate within the CI/CD pipelines, to not allow the situation to happen again in the future, but also to remediate the current overall situation. Number two, build from standardized base images. The third one was to update base images within hardened libraries and packages. Number four was to remove unnecessary components like those HP drivers I spoke about before to minimize that image. Number five, update clusters which would pull down the latest images from Microsoft. Number six, update images to the latest version. And number seven, work with the vendors to remediate any critical or high vulnerabilities that remain. Again, this story illustrates the importance of a good Kubernetes security hygiene practice. It was a true pleasure presenting securing Kubernetes in an ever-changing ecosystem for you. Thank you for this opportunity.